All right, good morning, everyone. Hello. My name is Michael. Today we're going to be talking about Android data. So I'm an Android engineer at a startup called Lyft. Before that, I worked at Expedia, and I had the opportunity to do this kind of code for tens of millions of devices. And it was a lot of fun to work with. I really like working with data and data structures, and so much so that I have a relatively popular SQL library. So today we're going to talk about Android data. There's different storage types and options you have. These are the ones that come with the Android OS. Shared preferences, the file system, SQL. So we'll talk about those. This will be good for the newer developers to get an overview of these. And for those who are not new to Android, we have the network and NoSQL storage types. I won't go into too much of the implementation of these, just because those fields are very big and implementation vary wildly. There's no standard for those. And even if you aren't new to Android, you might still get some use out of the other section, as I'll be going over some libraries that I like to use. So first, let's take a look at shared preferences. Shared preferences are a key value pair data store, and they're stored as XML. So this is good for a relatively small collection, just because of the verbosity of XML, and then you can only store like primitive data types, string, integer, boolean, float, sort of thing. Where you might use this in the real world. So for, like, say your game has an inventory, you could zip that up into shared preferences. I use this for saving application state, like, is this the first run of my app? Set that boolean as a preference, so I know whether to start up operations, or like which folder am I in. Shared preferences also back the OS user preferences, the shared preferences screens. So that's one way that they're baked into the OS. So this is, if you open up one of the shared preferences files, this is what it looks like. It's very verbose because of all the XML. It's just a string tag or a boolean tag, whatever type it is, with a name that is the key, and then the value is the contents of that tag. So in order to work with shared preferences, we need to get an instance of it. So there's this method off of a context called getSharedPreferences. It takes in two values. The first is the name of the preferences file, and this is relative to the internal storage of your application. And then the read mode, or the read and write mode. So the default now is mode private, and I think it always has been. There is mode world readable, so publicly visible modes, but those have been deprecated over security concerns, so you're generally best off using just mode private. So that was the standard way. There's some convenience methods. This is off of an activity, the getPreferences method. Just takes in a mode, no file name. That's because it uses the activity name, or the activity class name as the file name. So this is essentially the exact same code. In fact, I think I pulled this out of the source code for that method, with a minor change. Another method for getting preferences is off the preference manager. This is a commonly used one, as far as I've seen. Get default shared preferences, and this uses accept just a context for the argument. And what it does is it uses the package name plus underscore preferences, and that's what it uses as a file name for your internal storage, and it uses the private mode by default. So let's take a look at storing and retrieving data. So first, to work with preferences, you need to get your shared preferences instance. Retrieving a value is just as simple as calling like a get method. So get whatever type, get boolean, get string, pass in a key, and then also the default value, and that just returns that type. doesn't exist, it returns the default value. So in this case, if we launched our app for the first time, it would see that there is no first run key, and it would return true. And we can do things based on that. So if it is the first run, then we can modify or set that value to be false. The way we modify values in shared preferences is off of the preferences instance, we call it edit, and that gives us an instance of shared preferences editor. And what this class acts like is sort of like a transaction. So you change all your values, and then when you're ready to save it back to the file, you call commit, and it saves everything all at once. So if you call get after calling put, that value will be updated until you actually call commit. So working with shared preferences is very easy. I mean, there's a little bit of legwork with setting, and so for that reason, some people have written libraries to facilitate ease of that part. Then also, like, you can only save primitive types, so some libraries like complex preferences allow you to save complex types. They do that using JSON or JSON to serialize. So for a look at complex preferences, you call a static method off of the complex preferences class. You pass in a context and your preference name and the read mode, and that gets an instance. And from there you can just call put and get. It still works like a transaction, so you have to call commit. But here we're passing in a key of inventory and then this inventory object. So it serializes that into JSON. And then when you want to retrieve that value, you call get object with the key and then the class for the type of the object, and it deserializes it. I forgot to mention, like, if you have questions as I'm going along, I'd rather you ask them now instead of waiting. So don't forget your questions. Yeah.
Can you also pass in a list of objects?
Yes, anything that JSON can serialize, which is pretty much anything. Yes. So this is, I think the question was, is this for in-memory data store? So all these data storage types that I'll be going over is you can use them in memory, but this is for persistence to disk. So when you close your app, come back to it later, you have those values still. Next, we have simple shared preferences, and this is one of those libraries that just wraps shared preferences and makes it easier to do the setting, so you don't have to get an editor and do the commit. It commits every time you call set on a value. So to get an instance, you just create a new instance, passing in the context. And so the limitation of this is you can't define the read mode or even the file name. It uses the get default shared preferences method to give you that instance of shared preferences. You can fork it or modify the code to suit your needs, but that's what it does by default. So retrieving a value is just same as regular shared preferences. Get and then the type and the key and the value. But this is what it does to make it easier. You don't have to do the committing and the getting the editor. You just call preferences put the type. Typed preferences. This is something that was created based on Jake Wharton's sample app for Dagger. He had these classes in here that encapsulated not the shared preferences, but the individual preferences themselves. So this class is called type. This library is called type preferences, and basically you get an instance of shared preferences, whichever way you please. And then there's all these classes: Boolean, string, float, preference, and you create a new one by passing in your preferences instance and key and default value, and it will give you back that encapsulated preference. So now instead of calling get and set and passing in a key, you just call get or set or is set on the individual instance of that preference. And this is good for things like mocking data or dependency injection where you want to switch out values. So along the way, you'll see these charts and this is an illustration of like how easy this library is to use relative to other libraries that we're going to go over, how complex the data can be, and like how much data you should store to this type of storage option. So shared preferences relative to everything is very easy. You cannot have complex data out of the box. You can add that functionality using something like complex shared preferences. So the amount of data out of the box is like recommended to be low. So that was shared preferences. Let's take a look at the file system. So the Android file system is essentially the same thing as the regular Java I/O file system, so you'll be comfortable here if you're used to using the Java I/O API. There are some convenience methods added, and we'll go over those. And for Android storage, there's two different areas where you want to store data: the internal file system and external, so the SD card. So internal storage, by default, it's first of all always going to be available because it's located on the file system where the OS is. It has to be available. By default, it's only privately accessible. And when you uninstall an app, all of your files in that portion of the file system are also removed with your app. For external storage, it's not always available because you can mount your device to your computer. You can remove the SD card, and then it's not physically available. The files that you put on external storage are always going to be visible to the world, publicly accessible. And when you uninstall an app, in addition to removing all the files on the internal storage system, anything that's stored in this get external files dir will be removed as well. So I think you guys have a good idea of where you use files. But here's some examples, like an API request cache. Most libraries have a request cache, and that's what they do to store files. You can store a game state object if your game saves its state, or if you're editing like consumer files, like images, you would store those in the file system. So here's an example of saving some JSON to disk. We have this JSON object, which is the game state. We're going to save it at gamestate.json, so we get the contents of that file by doing toString on the JSON object. The method to note here is this on the fourth line down, the open file input. That's called a context, and that gives you an output stream in your relative directory. And then from then you can just do regular file API stuff. So that is essentially the same as doing this, creating a new file output stream, passing in a new file, which has the get files directory as its file path, and then the file name. So for external storage, you have to define some permissions, or request some permissions. For writing to external storage, this is the permission you'll need. And then for reading external storage, if you use this, then reading is implicit. And this doesn't really apply right now, but in future versions of Android, there will be this read external storage, so you can separate them both. So reading external storage is like a less scary permission, I suppose. Oh, I should note that you also don't need to define these permissions if you're using that get external files directory, because your private file you don't need to request permission. So if we're writing to external storage, you should first make sure that it's available. You can do this by calling on the environment class get the external storage state. That returns the enum, or maybe it's an int, and then you just compare that state to see if it's a type medium mounted, or if you want to see if it's at least readable, you can see if it's medium mounted or medium mounted readable. So you want to do this before you even try to write to or read from external storage, so you can't if it's not there. So here's some other interesting methods in the Android API that get, mostly what this has to do is getting you pass and streams relative to your app, relative to your internal storage directories, your cache, your external cache. This get external storage public directory takes in a type, which there are types for picture storage, other kinds of storage, notification, sound storage. Some libraries that are popular, this is relative, not particular to Android. These are from the Java world, but you can use them on Android. Apache Commons IO is one of them. Another popular one, which I use not just for the file system stuff, but for other things, is the Guava library. So with these libraries, you can do things like this. It just makes things easier. So instead of doing all your reading in a while loop on an input stream, there's this method ioutils.toString, and it takes in an input stream and then just gives you a string back. And then closing your input stream is just ioutils.close quietly. So it closes it properly and then swallows all the exceptions if there are any. This example takes a file and reads all the lines into a list of strings. This class normalizes relative paths. So Guava is very similar in a lot of functionality. This is another example of reading all the lines in a file to a list of string. This is taking a file, reading in all the words, and then adding it to a hash multiset to figure out how many times each word is used. This is taking a file and hashing it. And this is taking a URL and saving it to a file, all in one line. So this is the type of things that you can do with Guava and Apache Commons IO. Relative to other storage methods, the file system is pretty easy to use. The complexity of the data is lower, it's just a stream. But the amount of data is big, it's out there. It's recommended for large files. So that was the Android file system, and now we are onto SQLite. So SQLite is an embedded serverless transactional database. It's good for relational data. However, out of the box, there's a lot of boilerplate. And again, you can figure out real-world uses for this, but here's a couple examples. Address book, product inventory. So what you'll see in the documentation is something like this. This isn't required, but it's good practice to have these contracts for the tables you're going to be writing and consuming. So this class has a inner class with a list of columns, just so you have a reference for the column name to use once everywhere. When you're using SQLite, you need to have an instance of this SQLite open helper. And what that does is it requires you to perform all the actions that a SQLite database would need to do, like creation, upgrades, downgrades. It also takes in the database name and the database version. So once you've done all that, then you can create a new instance, passing in the context. It does all the creation if it needs to. From that database helper instance, you can get a database by calling get writable database, get readable database. If you want to do writing, get writable database is what you want. So let's look at retrieving some values. So there's a query method on database that takes in all the parts of the SQL statement that you would expect. So here's the column as part of the SQL statement. It's a string array with a projection of columns. So here we have the ID and the name. And then this is the actual method. You pass in the table name, the projection, any type of selections you want to do, so like the where clause. And then all those nulls are different parts of the SQL query that you can append, group by, having, order by, limit. What that does is it gives you back a cursor. From the cursor, This is behaves sort of like an iterator. So you move to the first record, calling move to first. Then you have to, in order to query on a column or get the value of the column, you have to first find out where it is in the cursor index by calling get column index or throw, or get column index, which doesn't throw, passing in string, which is the column name that gives you an index integer ID. And then once you have that, you pass it into the cursor, get whatever, get long, get string, and then that gives you the value. Again, a lot of boilerplate, a lot of code for doing something very simple. And then when you're done, you need to close your cursor. So that recycles the cursor and then you can't use it anymore. So for adding or inserting a row, we have to create this object called content values, and that acts like a map. It's just a map of keys and values or columns and values. For inserting, you call this method insert, and it gives you back the ID that it inserted, that it created when it inserted. So you pass in the table name and the values, and that argument in the middle, the second argument, is for a null column hat. So if you are inserting into SQLite or SQL, you can't insert a row that has no values. So if you're doing that, then you need to have a column that you can define here where you pass in this column hat that allows you to do that. In most cases, you probably are not going to do that, so you can just pass in null. And updating is similar. Again, we have content values with the values we want to update and the selection. So now we have to select which rows we actually want to update. So any row with this author ID. And then we call update on the SQLite database, passing in the table name, the values, and then the selection. So deleting is similar to inserting, except that we're not modifying, we're just deleting, so we have a selection. And then we just call delete with the table name and the selection in here. So because of all those slides, there are a few libraries that people have created to make things easier. These are called object relational mappers. They take tables and map them to Java objects. These are all in alphabetical order. You'll see I have a little bias on it, and I just want to make it quick. So Active Android, this is my library. The way you define tables, so forms often create the schema in the database and allow you to work with it. So the way you create the schema is by creating this class that will be mapped to the database. So this class extends model and is annotated with the class is annotated with the table name. If you don't pass in a table name, it just uses the class name. The columns are also annotated. To query the database, you can use this query builder language, or you can use SQL, just a raw SQL statement, and that gives you back a list of your type. Saving or updating is just creating the object and calling save on the object. So this style of ORM is called active record, where the record or the object itself knows how to persist itself and retrieve itself. You'll see a difference in the next slide compared to this style. Similarly, deleting an object can be done using the delete method. So that was active Android. This is green DAO. So DAO is a data access object, and instead of the model interacting with the database, there's one instance of this object that interacts with the database for all the objects. So in green DAO, you create a schema, you create all your entities and add properties to all the entities, and then you create a DAO generator, and then with the generator, you generate your schema, and that creates everything for you. Querying is done on the DAO object. So here we're pulling out all the posts. Saving is similar. You build up your object like you would in active record style, but then you use the DAO session or the DAO object to insert it. And then the same thing with updating, you just modify your fields and update it. And that row has to exist already in the database. And then deletion is similar too. Ormlate is another very popular orm, and this is uses the DAO style. Defining the schema is simpler than read DAO. Again, you query on the DAO, you create on the DAO, update, and delete. Sugar ORM is another one that uses like a mix of active record and DAO. So you define your schema like this. So this is the active record part. You're querying on the object itself, so post.find, and it gives you back what's a post. And then this is the DAO-ish part, where you save on this class sugar record. It's a static method. You just pass in the object. The same thing with deletion. So, about forms, a lot of people have a lot of hate for them because they try to do too much. They try to stop the user from breaking things or doing bad things. They abstract too much or create these leaky bugs that your SQL code won't work. A good ORM will try to be lightweight and get out of the way and let the user do what they want to do and just take care of the mapping. And as an engineer, you should use SQL, as much as you can when you can, so you have total control. The SQL query building languages are nice. I would use them sparingly. So relative to everything else, out of the box, SQLite is not easy to use. Complexity of data is high, or relational data, and the amount of data is also high. So there's trade-offs to all of these different types of storage options. So the network, this is one of those add-ons. Yes?
Do you know the speeds? Have you done a comparison of speeds? Because if you actually go
Between ORMs?
yeah, it's a green one, they promote themselves being the fastest.
Yeah, I haven't personally done all the benchmarks. I would encourage someone to do that because I don't think anyone has. At least with all the different types. I wouldn't use Active Android because of the speed. In fact, I switched from writing Active Android to writing something else that uses annotation processors to pre-write all the code. Yeah, you'll have to look around for that. I don't know off the top of my head.
We've done a bunch of that on good. I figured it out.
Pardon me?
We've done a bunch of that work.
Okay, cool. Yeah. I'd like to start. Yes. So none. So I would use this method, network, which we'll get into now. So with these next two storage types will be like a brief overview. I don't know that we have a whole lot of time left. Let's see. So network. Network storage is obviously over a network. There's two different types. There's file sync, think Dropbox and Google Drive, and then there's mobile backend as a service. And so it is like an API that you don't have to build. It's already built for you. You get cross-device and cross-platform storage, which is nice. There's lots of options, and they're all different. Obviously, this type of storage is not always available for sync if you're not on a network, but most of them have a local data store that you can persist to while you're waiting to sync. So sync libraries, the most popular ones in alphabetical order, Box, Dropbox Sync, Google Drive, OneDrive, and most of these have like similar feature sets. They do conflict resolution, things of that nature. Mobile backend as a service library. So the first two, Fastbox and Helios, those are open source and you have to host them yourself. The other three are hosted. Some are free sometimes, mostly they're commercial. And the types of data storage you see on these is mostly key value pair, tables, documents, and the interfaces all vary wildly. So this is just a huge mess of features on Fastbox. So like administration, user management, content management, file sync, data store, push notifications. This is a lot of the same stuff. Push notifications, logging. This one supports some iOS stuff. Dropbox data store has local and cloud storage and shared data stores that you can share between users, which is interesting. A feature they call webhooks, which is really just push notifications, as far as I can tell. Hindi as another backend as a service with cloud and local user management. This is a little more feature-rich than Dropbox by intention, I think. And the same with Parse, and I think this is the most popular by far. Again, push notifications, analytics. They have like social integration. And lastly, NoSQL, or not only SQL. So there are a few options out there for NoSQL, and I think this is just due to the nature of NoSQL, that the uses on embedded devices are not as plentiful as on servers. So generally they're like key value pairs or documents, or usually JSON documents. They're designed to be simple, and that's one reason you might want to use it over SQL, where you have all this relational schema to take care of and then migrate. And these are non-relational data stores. And again, implementation vary because there is no standard. Libraries that I've seen, Couchbase Lite is probably the most popular that I've seen for Android for embedded. JazzDB, Simple NoSQL is a new one. SnappyDB, WaspDB, so I'll go over all these briefly. Couchbase Lite is a JSON document store with a full query API. It has replication over the network for to the server and also peer-to-peer. JazzDB, again, a JSON document store with a full query API. It has a REST API and also a client API, so you can use this on your device. And then also have a server component. Simple NoSQL. This is a JSON document store. It's interesting. It's backed by SQLite. Interesting. The query API is more functional and less of a query API than the other two. So you'll have like filter and order functions that you do all your operations. SnappyDB is based on Google's LevelDB, uses snappy compression and cryo serialization. It's a key value store, and I think it uses like primitive types versus WaspDB, which you can use complex key and value types. And this also uses cryo serialization and is a key value store. So here's an overall overview of all the data types so far in more of like a binary, ternary type view. Share preferences, file system are easy to use. The network and NoSQL are sometimes easy to use. SQLite, network, NoSQL, I'll give you complex data sometimes. Anything but share preferences is good for a lot of data. And then the distributed models are network, and then sometimes NoSQL. So that's all I have. Do you have any questions? Yes?
Any performance gotchas that you can talk about?
I mean, not really. I mean, so the NoSQL storage types often try to emphasize the efficiency and speed of the libraries. As far as speed and performance of the basic group set, I would say share preferences is maybe the slowest. I mean, you're not going to see a whole lot of difference in all of them. They're all loaded into memory. I guess the more complex you get, probably the more performance issues you'll see. Yes?
Do you see any drawbacks using the active record paradigm as opposed to the data access object?
Maybe. So with the active record style, each object is a little more dense. It has subclass backing it, and there's code and method in there. So if that's an issue for you, then maybe that's something you want to steer away from. But I think for the most part, it's more of a preference of coding style. Yes?
I was the one that was tweeting you before the conference about Ollie. I know that you've been working on that before. Is there a reason why you didn't mention that today? Are you backing away from that?
Just because I haven't worked on it in a while, and I want to make sure it's really good before I really say anything about it.
I got you.
I mean, it's up on GitHub, so you can look at it. It has the basic functionality set as ActiveAnchor, but I think you could probably replace your ActiveAnchor with it right now, except that it doesn't really work well with other annotation processing libraries, which I hope to fix today by seeing Jake Horton's talk on annotation processing. All right, so if there's no more questions, thank you for coming. And